Step 18, I can solve and graph rational functions. Step 18 has a lot happening. There's a lot going on when we're trying to solve and graph rational functions. First thing we need to do is understand what a rational function is. A rational function is just a ratio of two polynomial expressions. They kind of look like an expression over an expression, or a fraction of expressions. That's what makes it a rational expression. Now let's think back to when we used to simplify fractions. When we wanted to reduce 8/12 into lowest terms, we basically just split 8 into its pieces that make up 8, and we did the same with 12. We split it into 3 times 4. Any number over itself, when it's a factor, when it's multiplied, cancels out. So when we have a rational expression, we're going to do the same thing. First, we're going to factor the numerator, factor the denominator, and if any of the factors are identical, they can cancel out to give us a simpler rational expression, or a rational expression in lowest terms. Let's practice that. On this first example, the numerator is 5 times x times this trinomial. So we want to think, how could I split this trinomial into 2 pieces? How could I factor it? Well, I'm looking for 2 numbers that multiply to give me 3 and combine to give me 4, which would be positive 3 and positive 1. And get in the habit of crossing something out once you've factored it so you don't think that it's still there. This has been replaced by these 2 factors. In the denominator, I have the quantity x minus 6 times the quantity x squared minus 9. I can't factor x minus 6. There's nothing that they have in common. At first glance, x squared and 9 don't have anything in common, but then I remember, oh wait, they're both perfect squares. So if you recall, to factor perfect squares, we need 2 numbers that multiply to give me negative 9, combine to give me no x term, which would be 3 and negative 3. And again, cancel that out. So now I have 1, 2, 3, 4 pieces in the numerator, 1, 2, 3 pieces in the denominator. What pieces will cancel because they're perfectly identical? These pieces. So now I'm going to write what I have left over. 5 times x plus 1, all over x minus 6 times x minus 3. Now, frequently, it's so common, people want to take this x and cancel it with an x down here. Or they might want to take this x and cancel them out. That is illegal. You may not do that, and here's why. This might sound kind of silly, but these 2 terms that are together in the parentheses, think of them like a marriage. If you try to cancel out one without the other, it's not going to end well. Right here, I was able to cancel the x plus 3 with the x plus 3 because both couples canceled out. But right here, whenever you have 2 terms joined with an addition or subtraction sign, they are bound together, and you may not cancel one part of them. Right here, x is not connected to 5 with addition or subtraction, so if there was another factor of x down here, I could cancel it. It's a tricky concept, and that's where you will probably make the majority of your mistakes. Let's talk about where this expression would be undefined. What that means is we want to look at the entire denominator and think, what value of x would make this denominator turn into a 0? So I'm going to rewrite the factors. We have x minus 6, x plus 3, and x minus 3. There are 3 different values of an x that I could put in here, and it would make this entire thing 0. The first value is a 6. When I put a 6 in for x, I I end up with 0 times 9 times 3, which is 0. You see how just this becoming a 0 makes the entire thing a 0. When we want to figure out where it's undefined, we literally want to take each piece and set each piece equal to 0. X minus 6 cannot equal 0. X plus 3 cannot equal 0. X minus 3 cannot equal 0. If these equal 0, the denominator is 0. So we solve. We add 6 to both sides. X cannot equal 6. We subtract 3 on both sides. X cannot equal negative 3. And we add 3 to both sides. X cannot equal 3. So under these conditions, this expression is undefined. And you might look back and say, oh, but we canceled out this factor. But it was still part of the original problem, so we still have to take it into consideration when we're determining where X is undefined. Let's try another one. Let's factor our denominator here. Our numerator is already factored. There's nothing else I can do. Y times y gives me y squared. I'm looking for numbers that multiply to give me negative 6 and combine to give me negative 1. Well, that gives me 5, that gives me 1, but I want negative 1, which means I need to change my signs to the other column. This gives me negative 1, so that is my winning combination. Y plus 2, y minus 3. Now we think about canceling. Y minus 3 cancels with y minus 3. Y plus 2 can't cancel with y plus 4. Oh, here we have a factor of y and a factor of y. Notice these y's are not added or subtracted to any other number, so they will cancel out. And what I have left is 4 times the quantity of y plus 4 over y plus 2. You can leave it like that. You can distribute if you feel more comfortable and get 4y plus 16 over y plus 2. Both of those perfectly good answers. We also need to list the restrictions. Remember, we had a y plus 2, and a y minus 3. Y cannot equal 0. It cannot equal negative 2. It cannot equal positive 3. On the next term, or in the next problem, we're broken down pretty well until we get to this trinomial. So let's break it apart. Z, looking for things that multiply to give me negative 8. And combine to give me positive 2. Well, this works. Those combine to give me 2. That's my winning combination, z minus 2, z plus 4. I can eliminate this. The denominator is already factored. Real quick, before we start crossing things out, let's talk about the domain restrictions. Z cannot equal 1. Z cannot equal negative 5. And z cannot equal 2, because 2 minus 2 is 0. Again, if it helps you to write them out and do each piece, solve each piece, that's totally fine. But as you do a lot of these problems, you're probably noticing some patterns. All right, let's think about canceling. I have a factor of z minus 2 that cancels, factor of z plus 5 that cancels, and that's it. So my final answer, I write what's left. 2z times the quantity, z plus 4, all over z minus 1. I can put that in parentheses if I want, but there's nothing else in the denominator, so I don't need to. So this would be my final answer here. I have my simplified rational expression, and I have my domain restrictions. Let's look at the -1 trick. Let's factor as much as possible. What do 4w squared and 3wy have in common? Well, they don't have a common coefficient factor, but they do both have a w. And when I factor out a w, I'm left with 4w. W times 4w is 4w squared. And when I factor out a w for my second term, I'm left with 3y. At first glance, I don't have any identical factors. I'm going to rewrite it. I have w, 4w minus 3y, w plus y, all over 3y minus 4w, and 5w plus y. Now, as you're examining this closer, you might notice these are so close to being able to cancel out. 4w, take away 3y, 3y, take away 4w. They're complete opposites. When that happens, you may cancel them as long as you pay for it by putting a negative out front. In essence, we're factoring out a negative here, which creates 3y minus 4w, which does cancel. But when we factor out that negative, we need to write it down. So my final answer is -w, w plus y, over 5w plus y. Pause the video and try this next one and see if you can get something to cancel out. Alright, did you factor out a z and have x minus 4 left over? Notice in the denominator I rewrote z squared as z times z so you could easily see how the z's cancel out in front. And these factors were opposites, so I wrote a negative and canceled them. It looked like nothing was left on top, but it was a -1, and in the denominator, z. And notice I would also have to say that z could not equal 0, and it could not equal 4, looking at our original problem. Oh, excuse me, I realize we have two different variables here. Z could not equal 0, x could not equal 4. That would be better. All right, now that we can simplify complicated rational expressions, let's try to multiply them. And when we multiply them, we're going to multiply them just like we multiply fractions. Multiply across the top, multiply across the bottom. Cancel things out when we can. Same thing with dividing. Dividing by a fraction is the same as multiplying by its reciprocal. So for this first problem, we have two choices. One choice is to strictly multiply everything across the numerator and multiply everything across the denominator and simplify at the end. Let's try it that way first. 6 times 15 makes 90. C times C makes C squared and D squared. In the bottom, 5 times 8 makes 40. A times D, I just like to keep things alphabetical. And now I have to simplify. 90 and 40 cancel, become 9 and 4. D squared and D cancel, leaving a factor of D. So my final answer is 9c squared d over 4a. That's one way to do this problem. Another way would be to go back to the beginning here. Instead of just multiplying, first think, well, could I cancel anything? Sure. 5 and 15 cancel. The factor of d cancels with d squared to leave a d. 6 and 8 cancel to give me 3 and 4. And now I'm going to just multiply across once I feel like I've canceled out as much as possible. 3 times 3 makes 9. C squared D over 4A. We get the same thing. Either way we do it. So you need to look at these and try to figure out what would be more comfortable for you. It's totally up to you. Try them both ways, see which way feels more comfortable. I will tell you, after doing these for many years, I prefer to simplify first and then multiply. But it really is a personal preference. You will get the correct answer either way. Now when I multiply, I end up with 6d squared over 6c squared. Notice I had more simplifying that I could have done. You should always check your answer. Is there anything else? Yeah, these 6's cancel. My final answer is d squared over c squared. Dividing is not so terrible. We're just taking and turning it into a multiplication problem just like we had. We're going to change that division sign to multiply. We're going to put the numerator in the denominator and the denominator into the numerator. And actually, we're really glad we did that because now a lot of things will cancel. Just took care of all my coefficients. Now I'm going to look at x values. Now there's an x here. That leaves an x behind. Y values. 3 on top, 1 on the bottom. Where are there more? Right here. How many more? 2 more. A squareds cancel. And I'm left with a factor of b. So when I multiply, going across, 3 times 5 makes 15. Everything else is canceled out except y squared. And in the denominator, after I multiply across, 1 times 2 bx. That's all that's left behind. Go ahead and pause the video and try this next example. Did you end up getting 2 ninths? Hopefully. As you canceled all of the other variables, this is all that was left behind. Problems will get more complicated, as you can see here. Here, we need to factor it first because we wouldn't want to multiply this out. That would get pretty terrible, even with the box method. So everywhere I see a trinomial, I want to break it into its 2 binomial factors. X, what multiplies to give me negative 16? Negative 1 and 16, negative 2 and 8, negative 4 and 4. Changing my negatives to the right side, I have a winning combination. Negative 8 and positive 2. In the denominator, x minus 8 minus 8. Negative 8 and negative 8 are positive 64. Negative 8 makes negative 16. And to the right, x, what multiplies to give me 6? 2 and 3. And 2 and 3 combine to give me 5. Now we are ready to cancel factors. X minus 8 cancels with x minus 8. X plus 2 cancels with x plus 2. X minus 8 cancels with x minus 8. And my answer, all that's left, there's nothing on the top, so I put a 1. X plus 3 on the bottom. Let's try this division problem. First, we need to rewrite it as a multiplication problem. By multiplying and flipping the second fraction. And now each piece needs to get factored. My first numerator is a difference of squares. It's x plus 4 times x minus 4. My next numerator, y and y, what multiplies to give me negative 18, and it's okay to list all of these things, 1 and negative 18, 2 and negative 9, 3 and negative 6, to find your winning combination. Y plus 3, y minus 6. Next, is there a common factor that I can pull out? There sure is. I can take out a 12. 12 times y is 12y. 12 times 3 is 36. And my final piece that needs factoring, what multiplies to give me 32? 8 and 4. That also gives me 12 as long as they're both negative. Now we're ready to cancel our factors. X plus 4 doesn't cancel with anything. X minus 4 cancels with X minus 4 on the bottom. Y plus 3 cancels with Y plus 3 on the bottom. Y minus 6 doesn't cancel with anything. So my final answer, I'm just going to write my factors. X plus 4, y minus 6, all over 12 times x minus 8. Complex fractions are the last thing we're going to talk about in today's video. All this means right here is divide. What this literally translates to is a plus b over 4 divided by a squared plus b squared over 4. And now this is a problem just like we had above. No problem at all. We're simply going to rewrite the first fraction. We're going to multiply by the reciprocal of the second fraction. And when we do this, the 4's cancel out, and my final answer is a plus b over a squared plus b squared. So don't let the name confuse you. Complex fractions really aren't too bad. You just have to remember that a fraction over the fraction is the same as a fraction divided by a fraction, which is the same as a fraction multiplied by the reciprocal.